All right. So let's zoom in a little bit. Number 19. So if you look at collisions, all right, you look at collisions, all right, the virtual lab was kind of based on that. However, these two, well, we'll walk through. So a 0.5 kilogram ball was traveling at 6 meters per second. Collides head on with a 1 kilogram ball moving in the opposite direction at 12 meters per second. The 0.5 kilogram ball bounces backward at 14 meters per second. Okay, so A says find the speed of the second ball after the collision. Okay, so a few things we got to look at. All right. Now, once again, we look at our paper. What's our equation? Well, we basically kind of been hitting. What?
You should make a point without even noticing
You're hitting it.
collisions.
Wow.
How'd you
Man.
miss that?
I don't know.
That's a good one.
Wow, I feel like I should have taken advantage of that. Okay, so if we check this out. All right, so my initial, so mass of 1, volume 1, mass of 2, velocity of 2. Okay, I'm going to zoom in a little bit so you guys can see that a little better. Okay, and then that's going to equal velocity, I should say final. Mass 2, velocity final, object 2. Right? That's all we need. So we can plug in our numbers. Okay, so try plugging in our numbers. Okay, let's see what we got. 0.5, which is 6, plus -1, -12 is -14 plus 1 times velocity final. Hopefully it looks something like that. Right? So when you solve for velocity final,
Nobody noticed I'm trying to meet by the time I'm asleep. I was reading for
I noticed. I was like,
can you send me an
my
email?
CCP class, the next thing I know, it was 10 minutes past the time that I was supposed to be on my meeting.
I got -2. How'd you guys, is that what you guys got?
oh, this is -4.
How did you get that? Wait.
Because it's -14.
You use your negative velocity. Did I
That's
plug it in wrong?
No, I tried it. -9
Couldn't it be plus or minus?
Negative
Or plus or minus
Yeah,
2.
no.
Because you're not
No, I
sure which
just
way
said
the
no.
ball is.
I just said no.
It's gonna be going left versus the big
Yeah, I
ball.
got it.
But how do you know it's coming from that direction?
So-
What if the ball's originally going?
Next question. Does that make sense?
Yeah.
You good on that? Yes.
Okay, so why is on the left half, the negative is on like the ball on the right, and then the negative on the ball on the left?
Okay, so if you look at the question,
Little ball, big ball.
if you look at this question,
The little ball goes this way.
so this initial velocity is going left, right? So the initial velocity is going 12 meters per second, but it's going left, so we have to signify
Okay, I got it.
negative.
Yep. I got it.
Should we just assume that like the first object in this question is going to be traveling in the positive direction? Like, or
Because it
should
could
we,
be
should we
plus or
put
minus.
like,
If I don't provide a visual, yes.
the answer, like, if this is on the AP exam, should we do like 2 meters per second in the direction of the second ball?
They would accept that. Yeah, as long as you have that direction, yeah.
Direction can really be anything, right?
All right, and then, so you got it. So backward at -14, so after the collision. -14, yes. Dylan?
Because be positive too for the second ball. The speed, but no direction.
Well,
I was free of speed in the last year too. And then,
that's tough because our you know. Find the speed of the second ball. The speed would be 2.
yeah.
The speed would be 2. Yeah. Now, if it said velocity, it would be -2. Yeah. All right. So the part B, let's check this out. It says, what are the initial and final kinetic energies? Taylor, how are you doing?
I am not very focused.
Whoa, why not? First day back after an entire week?
I've been like this since I came back from my quarantine.
Oh, I get that. Fair enough.
Kinetic energy formula? Though?
Absolutely.
1/2 mass velocity squared.
I thought you said you weren't ready. All right, so my kinetic energy is 1/2 the mass velocity squared. Okay, so if we check this out, let's check our, do you want to do initial or, well, let's do initial first. Okay. All right, so my initial, I'm going to do initial down here. So 1/2 mass of object 1, my initial velocity, 1 squared, plus 1/2 mass of object 2 plus its initial velocity squared. Okay?
When it's like initial velocity, is that when the balls first hit each other? Or is that like when they start rolling?
So when it says initial, like what is it before they hit? Right before they hit. Okay. And then do the same thing for the final. Okay, so try the initial first. So once you plug that in, anybody get an answer for that? 81? So everybody's good? So the kinetic energy initial
Oh, because it's square.
is 81. What's the final?
It says 51.
51?
Yep.
Everybody get 51? You guys need me to show that, or are we good? We good? Now, we got to think about this. What type of collision? Is it inelastic or elastic?
Analyze.
Inelastic. Why do we say inelastic?
Would be outside.
Well, if we go back to, let's go back to long way. Oh, whoop, past it. So, is our energy conserved?
No,
So it's inelastic.
I was about to say because it's not bouncing off the anything.
Now, if we look at this, did the objects stick to each other? No. So what specific did we get?
General.
General inelastic. Does that make sense? You guys remember that slide from a while? Lori back.
I like watched a video about it. Isn't there like no such thing as elastic collision? Like things that really never happen.
Yeah.
That's unfortunate.
You'd have to, yeah. Where were we? Were we on 18? Oh, 19? There we go. Okay. Let's check out 20. Now, honestly, when you guys get problems, when you guys start work, I mean, the AP test is 3 months away, so we still got plenty of time. If-
Until the day before.
So what?
Therefore, I don't start until the day before.
Fair enough. You guys will be well prepared.
Or not at all.
There's problems that say, like, they recommend the amount of time to work on a problem, right? So it says, hey, this problem takes 5 minutes. All right, it might take 3 minutes to 7 minutes, right? There's problems that say this problem's going to take about 35 minutes. You have a 35-minute problem.
I didn't see
That
that.
scares me.
There's a 35
Dude,
minute
okay,
problem
hold
the
on.
exam.
You like
Yeah, can we see an exam?
I'm canceling my exam.
I'm not saying it will be impossible, I just wanna know how much it works.
Do I really want to spend $95 on a 35-minute question?
2 35-minute questions.
Yeah, but if you think
That's
about
all
it, if you
time.
pass it, then that's like 3 college credits for that's actually like $1,000 for a class in college.
If,
Yeah. You gotta get it.
and it's gotta be a 4 or 5, because 3s are just mediocre.
Hey, if you get a 3, that's passing. That's all I'm saying.
I'm getting
Yeah,
3.
you still pass.
No more.
If you get a 3 though, you get college credit.
Not as,
Some college.
some colleges.
The college that I'm going to.
I'm really curious of what this will look like. Would that be with like electrical circuits, or would it be a problem like?
Where are you going?
I don't know.
You guys got me distracted.
I'm going
That's far away, not really.
It's only if there's 2 hours.
And I'm not. I love that for him.
And also,
Oh, Mr. Bowers, I forgot to update you, but I did get into UC.
That's what I'm talking about.
And I got into my program.
Sweet.
Where you
That's
going?
like a win-win.
Biology. I have no idea why.
1,030 questions? What?
Huh?
I asked my,
Uh,
I asked Mrs. Dunkel, I said, would I be good at AP physics? And she's like, yeah, if you get me. And I was like, okay. And I know, she's not here this year.
All right. Oh, here we go. Let's do a.
Oh, he's not kidding.
No. This is don't no. I'm looking for a momentum one.
Are we going for like a
It took me a minute to scroll through one.
I thought there was one problem.
No. Force velocity.
Oh.
Oh, we haven't got the torque yet. Went too
I'm
far.
not taking this
What the heck? What is two force? I want to use these type of problems. I just want to get an example. A block launcher.
The closer these exams get, the more scared I am.
Let's check out an example
It's
problem.
gonna be like 2 words. It's like a study.
I have 3 of them to take.
Now I'm trying to think if these show the time or if the practice exam show.
I'll probably be fine in stats and psych. This is one that I'm most.
Are there questions that take like hours to do? Or is like 35 minutes?
I don't know.
Like an hour to load on this. They really have to work. Oh no.
I feel like practice tests are like.
Like they even managed to do
Those were. I probably got at least like 75. Yeah, like that's not. I'll stay it. Honestly, I feel like.
There we go. Here we go.
So say I get every single multiple choice question correct and I get the
Oh,
whole response.
this looks similar.
completely wrong.
Oh, that looks pretty similar. See, we're off to a good start. We're off to a great start. So, here, you have an hour and a half for 5 questions.
Oh, freaking word.
How long is this test?
I don't.
5
Five
questions.
questions.
So, this first question is worth 13 minutes. Okay.
Where is the hour one?
See.
2 minutes, 2 minutes, 2 minutes.
Question 2 is 25 minutes.
Oh my god. How many parts are each question?
Acceleration. This is electricity,
Oh.
so we're not going to be using that too much at all. Actually,
Wait, so that's gonna be on the exam.
I thought they were dark subjects.
it won't be on the exam. This is a previous exam.
Oh, and then move it to another.
Yeah, that's actually so. The electricity is
It's only 5 questions.
physics 2 now. Question 3 is another 25-minute one. I mean, 13 minute. That's an easy one.
Yay.
And the last one is 13 minutes.
That last one.
That's fine.
So we'll work our way up.
One extra minute.
Now, there's a lot of words here.
Dude, that's right.
And we're going to practice looking at these type of problems. You pick and choose what information is valuable to you.
They just give you lots and lots and lots. You don't really need it all.
They give you lots of words. They make problems very wordy. All right.
Sounds like you.
Where we already know how to do springs, right?
I know.
We'll need a review. But we already know how to do springs. It's frictionless. How beautiful is that? You only have to consider friction.
Very nice.
And just solving different types of problems. Okay? So
Stop it. In the museum. Stop.
just a heads up of what it looks like. Okay. So let's do one more problem. One more problem.
We should do the explosion.
Let's see.
I'm sorry.
I would think there's gonna be.
I think so. Talking about springs, we're gonna try one example out. These are springs. So A 15 kilogram block is attached to a spring with a force constant of 500 newton meters and is resting on a frictionless horizontal table. Oh, fun fact. So, do you guys do Valentine's cards? Anybody ever do those?
Actually, I had to make one from that.
So, oh man, I got this. I gotta show you guys real quick.
We do like use these equations to make like all different like types of like there's like cards and
Oh, yeah.
infinity and all that.
So, there are no 3 words better than I love you, right? If you're talking to a Valentine, there are no 3 words better than I love you. That's very blurry, but we can do it. And then at the bottom, friction is negligible and holy is massless. Those 3 words are better than I love you. Friction is
Depending on the
negligible.
night, yes.
So if you're dating a physicist, don't say I love you.
Just
Friction
hand them a card.
is negligible.
Yeah, cross out I love you on the card and put frictionless.
All right, so frictionless horizontal table. Suddenly, it is struck by a 3 kilogram stone.
That wasn't necessary. Hold on, I've got a hammer to friction. You're weird.
I don't know what's happening there. 3 kilogram stone traveling horizontally at 8 meters per second, right? Whereupon the stone rebounds at 2 meters per second horizontally to the left. Find the maximum distance the block will compress the spring.
I hear what she's going on.
Okay. So, got a few things here.
I can't hear you.
So we have to find compression.
I was making.
Now, when looking at this, let's go to the last problem. I'm just going to close out. We got the problem here. When we look at this problem, we are on 20 point. Now, we have to use our same equation. So we have to find the final velocity of the rock, or of the stone. Okay? So first find the final velocity of the stone. Okay? Oh my gosh. Okay. It's all sense now. So, same equation we've been using this entire time. So 3 kilograms. Three. Okay. So solving for velocity final, what did you guys get?
Whatever 18 divided by 15 is.
Two?
I got 2.
Brady got 2, so I'm going with Brady.
Let's go, Brady!
I'm just kidding.
2 is correct.
So 24 plus 0, here's -6, so you got to add 6 over. So
Oh,
30.
I subtracted 6, my bad.
30 divided by 15, velocity final is
I
2.
should have added. No.
Okay.
I would do it.
So now, you guys ready for this? Do you remember the golden equations?
I sure don't.
I remember the golden rule.
These funny ones right here.
Kinetic energy initial plus potential energy initial plus elastic potential energy initial
Oh,
plus
No, wait, we're going back here?
Oh my god.
work non-conserved
no. Oh,
creates kinetic energy final plus potential energy final plus elastic potential energy final. Yes!
My question is
Yes.
how many of these are gonna cross?
That's why I love this problem.
I feel like every single unit has a problem.
I knew she went on to the explosion.
Alright, now, but do you remember the best part of this type of problem?
You can cross some stuff out.
You didn't even.
Most of them are zero. So, the best thing is, when you're on a surface, what's your potential energy? Zero.
Oh!
Let's get rid of those.
That's kind of catchy.
Let's get rid of those.
Very
Okay.
catchy.
Now, before, oh, I took it off. Before the ball hits the spring, before it hits, what's the elastic potential energy? Zero.
Yo, even
Let's get rid of that. It is frictionless. What's that mean?
I like this a lot better.
Okay.
This is man.
Now, we found the final velocity of our rock. All right. So essentially, it compressed. The final kinetic energy of the rock is just going to be zero. Right?
Why?
Because it's going to hit the spring
We're taking it to the point where it's paused.
Oh, okay.
and it's going to be stopped. So let's get rid of that.
Yo.
Yeah, I'm just a lot more than-
This is
good.
Okay.
This is man.
Aha.
So, what's my kinetic energy equation?
1/2 mass velocity squared.
1/2 mass velocity squared. What's my elastic potential energy equation?
No idea.
Ooh, wait, hold on. KV squared, 1/2 KV squared. Is
No.
that it? Am I close?
No way. No way.
Squared.
Oh.
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 Okay.
Still, that is very.
That was very impressive.
I had no idea.
So, if we look at these two equations, let's try it out. Well, we already know 1/2. What's my mass? Well, my mass of the block here is 15.
What was that?
My velocity I just solved was 2, so 2 squared.
Wait, but are we doing
What is my displacement of the block? What is my displacement of the block? That is exactly correct.
Oh, I pressed the button.
Okay, yes.
Oh, I'm not doing drop this stuff.
Why are you eating?
That's what it sounded like.
Oh, well, we sorted?
That was a full, like,
Yes.
I don't want to.
I don't believe it.
So, when we solved back, let me see. When we solved back here, yeah, right? So, what that would be, let's draw this out.
I can't believe it was so close and then it goes around this.
Here's your spring. So
I have a photograph.
there we go. So the ball hit the block, right? Now, the final velocity of the block, eventually the final velocity will reach 0. But we're just looking at what was the velocity right after it made contact. Right? So right after this ball made contact, the velocity of the block was 2 meters per second. So when we're looking at the compression, so now we're looking only at the compression. The initial of the compression was 2 meters per second, where the final will just be a 0. So it's kind of like, it is kind of confusing because it's final and initial, but it's just based on the question, you'll have to apply it differently. All right, how do we feel? Pretty good? All right. Tomorrow, we're going to hit some collisions or explosions. Okay.
We're watching more Mythbusters.
Probably watch some movies.
That's
Have you
good.
watched the Blitz and do math explosions?
I don't see
This
why not.
episode where they were stranded on like a deserted
Oh,
island with the duct tape.
Yes, that was awesome.
I
It
don't
was
think I have.
such a good episode. It was hilarious.
They must have gone on an island and gone to duct tape and just make a bunch of crap in a duct tape.
But like it's hilarious because they don't even try to hide the fact that they're staying in a hotel. Like when they spear a fish, there's like takeout like containers right behind them.
Oh, wow. Now, guys, the crazy thing is, I probably don't even need to teach you guys explosions.
Oh, I was like in general.
No, like I will, but I really honestly don't need to, because if you look at our equation, right? If you look at our equation, it's the same thing over and over. However, our explosion here is we're going to have that, but our momentum final, we're going to have 2 different masses. Because it's going to explode into 2 different
So it's not like shrapnel explosions? Because that would be cool.
Wait,
So it's all kind of the same thing. So anyway, hyped up for some explosions. We should do some explosions.
We should.
You might get another email.
Yeah.
You better email.
What's this firecracker sound coming from Mr. Bowers?
Danny Murrow, can you come to the receptionist desk? Danny Murrow.
Well, I mean, you could, but I'll have to find something. Make tomorrow a little exciting. Do an explosion lab. I don't know if we have a canister to do that. Like do a bomb calorimeter. Calorimetry. Analyze, calculate the heat and how the heat converts to energy. Convert that energy into kinetic energy.
You can even figure out what chemical it was, just from the energy.
True. Use an NMR. Yep. Yep. Have you heard back from the Rose Holman?
Not yet.
Not yet. I was here. You too.
For some reason, you would have to have
Andrews.
How's it going?
Go get him,
Hey, Laura.
Yes, I'm working.
I was just saying, could you walk in that way?
It's a disclaimer,
Okay,
disclaimer.
never mind.
No, that you don't think we'll have it. She just screamed for reason.
Oh.
She just like screamed for reason. It's hard to get.
I just use that plug in.
It's so funny.
Hey, test that.
Yeah.
We did it. We took part off because that's snowing before. And then we sent it all over. I love that. Super cool. Nice.
Not even.
Very cool. And the hair.
All right.
From yesterday. I like it. I washed it. It's awesome. Yeah. So Nicole, how are you?
Oh, good, how are you?
Yeah. I thought for a minute. Thank goodness.
Of your driveway?
Yeah. Thank
I was
goodness.
thinking about that this morning.
And thank goodness she did because the neighbor, so we have a shared driveway. And the neighbor happened to be out shoveling at the same time as Nick was shoveling. And so they gave me a nice little digging feet out because my wheels were spinning and digging.
Yeah.
So then Nick was literally pushing on my vehicle to get me out.
Yeah. Good day. I was
So that was yesterday, and then they did a really good job of clearing it while I was in dance.
Yeah.
So then when I came back, I was like, okay, good. Made me more confident I could get out.
Yeah, I was like, I had to dig myself out of my car too. And I'm not even in a crazy driveway. I'm just right outside.
I
and
would
it
not have
just-
been able, and Nick would have been so mad this morning if I would have it wake him up to be like, hey, can't get out of the truck.
Yeah. Thank God for my husband who starts my car so it warms up.
Nice. I haven't heard of start, so
Okay.
that part's okay.
Yeah.
It's just the actually getting.
Yeah.
Just to stay on score line.